4.4, the topic is on climate change. And there's so many talks about climate change, so let's just try to simplify what you need to know. So let's divide it into 4 quadrants, or 4 big ideas you need to know here. First of all, you need to know what are greenhouse gases, and you need to know that they are okay. We need greenhouse gases. However, the other quadrant is here, I'll put not okay. And the last quadrant is abstain, or no comment. You realize later why I put no comment for this one. Alright, so let's talk about greenhouse gases. The most abundant greenhouse gas are carbon dioxide and water. So where's this carbon dioxide coming from? Cellular respiration, product of cellular respiration of animals. It's also released back into the atmosphere through the process of combustion. So combustion of our fossil fuels to get energy, we release CO2 back into the atmosphere. Water, the top 2 most abundant greenhouse gas. Where did this come from? Evaporation from the ocean, and transpiration from plants. So the other greenhouse gases that you need to know are methane and oxides of nitrogen. I'll put NOx there. Methane, as mentioned in 4.3, is released by anaerobic microorganisms, and we find this in marshland, peat, waterlogged soil, so released back into the atmosphere. Oxides of nitrogen are from use of industrial products. Sorry, delete industrial products. I'm thinking of CFCs. So these are from vehicle exhaust. This can also be naturally produced by bacterial organisms. So these are the 4 greenhouse gases. Top 2, and these last 2 are present in large amounts, but they don't really stay long in the atmosphere. And let me just mention that oxygen and nitrogen in the atmosphere, they're not considered as greenhouse gas because they are too small to absorb radiation from the sun. Alright, so let's talk about why is it okay? Why are greenhouse gases okay? You know what a greenhouse is? So it's a glass type of house where you can grow plants. Those are plants. The idea is you're using glass because glass can let in sunlight, but then it bends the light, so the light won't be able to escape. Therefore, it stays here. It warms the house. Plants can grow. Same concept for our greenhouse gases. This is the earth. We need warmth here. Because in the absence of greenhouse gas, the average temperature of the earth is measured to be about negative 18 degrees Celsius. You already know 0 is cold. How much more negative 18? Now, because of greenhouse gases, the average temperature here on the earth is about 32 degrees higher than 18. So we're warmer here on the surface. Quick explanation of how this warming happens. So you have the sun, emits radiation, and about 30% of that radiation is absorbed in the atmosphere. So it doesn't reach the Earth's surface. So about 70 to 80% reaches the Earth's surface. And once it reaches the Earth's surface, it's actually reflected back into the Earth. So about 70% of the radiation reflected back are absorbed by your greenhouse gases, which re-emits that radiation back to that back to the surface of the Earth, and therefore warms the surface of the Earth. Right, we have a warming effect thanks to our greenhouse gas. The problem is, so we'll get into the next quadrant, not okay, because there seems to be an increasing amount of greenhouse gases in the atmosphere. So let me put more dots here. And what will you expect to happen if you have more greenhouse gas? There's more emitting back of the radiation to the Earth's surface. Therefore, the surface becomes warmer or hot. Alright, the big thing about climate change advocates is that we have been seeing increasing trends in warming of the Earth's atmosphere, and they were saying that this can be correlated with increased CO2 in the atmosphere. We have increasing temperature rise, and this graph might be very familiar. We've been measuring the CO2 levels through the years, and there seems to be an increasing trend in the levels of CO2, and this could be also correlated to the increasing warming of the Earth's atmosphere, and this can all lead to climate change. Once upon a time it used to be called global warming, but then scientists cannot actually predict the exact effect of climate change. It depends on where the area is located, the availability of water, amount of CO2 in the atmosphere, etc., etc. But it's not okay, and here are the different effects that we can see. First, higher rates of evaporation, which means more rain, which means it can lead to flooding and thunderstorm. What else? High evaporation in areas where it's far from bodies of water. High evaporation can lead to drought. So this is completely raining and this is completely drying. What else? High evaporation. We have melting of your polar ice caps. That can also lead back here to flooding. So this can also lead to habitat loss if you think about the different ecosystems in the colder regions. What else? Okay, I'll just put etc. But keep in mind extreme weather changes or climate change. Very hot, very cold. Suddenly you have storms, tsunamis, earthquakes. It's basically the Earth trying to react to that increase in its temperature. So the last quadrant here is the no comment. This is just to basically balance or think about the impact of increased CO2 in the atmosphere. Does it really lead to this? So we have a few no comments here. First of all, it has been studied in ice caps that there is really a normal increase in CO2, then decrease, increase, decrease. That's normal. And it's also been studied that thousands of years ago, the Earth has gone through extreme freezing, and then hot, freezing, and then hot. So whatever is happening to us is a normal cycle. Another argument of the no comment group here is that if you consider the activity of the sun, sunspot activities, yes, it is warming, but this is also real, sunspot. And if this happens, there are portions of the sun that suddenly becomes really cold, and that will affect the warming here on the Earth. So even if CO2 is increasing, but there are sunspots, so that, hand in hand, it's warming, but this is going to be cold. So maybe there's no overall effect. Another one is if you consider the orbit of the Earth around the Sun. Of course, there will be times when the Earth is farthest away from the Sun, so we might not be able to feel the drastic effect or changes of warming of the Earth. Or when it's really close, then it might be very extreme. Another one is natural processes. So, intermittent volcanic activities. You know that right after a volcanic eruption, there's a phenomenon called global dimming. So these ones we cannot control. What if it happens? Then global dimming, the Earth will cool down. Or changes in currents of the ocean, which distributes heat around the surface of the Earth. That can also determine how our weather or how the climate would change eventually. So different kinds of natural processes can lead to changes in climate as well. So it's not all because of burning of fossil fuels, emission of CO2 in the atmosphere. And so the purpose of this unit is for you to understand how these greenhouse gases affect the warming of the Earth, and by studying whether there is a correlation or not, we can evaluate the claims of how CO2 is related to the warming of the Earth, or how we evaluate whether the use or burning of fossil fuels really is to be blamed for the increasing warming of the Earth or climate change. So I believe topic 4.4 is an open-ended topic. It's for you to research, read about it, and take a position. Thank you.